Okay, let's try thinking a little bit more carefully about what's going on here. In real life, we have lots of different houses of lots of different shapes, some big ones, some small ones, some with a flat roof, I don't know, maybe they have chimneys, some with 2 bedrooms, some with loads of bedrooms, and maybe a basement, who knows. And in real life, there are prices. So, how do we get from the house to the sale price? How does that work? Well, the buyers and the sellers meet in the middle, and they meet, and somehow that interaction, maybe together with an agent, creates a price. Now, this whole process is exceedingly complicated. I'm not quite sure where we would get if we tried to model this process. So what do we do in machine learning? Well, it's quite simple. We pretend that real life runs according to some true unknown function, which takes all available information about each house into this function and returns a sale price. We do admit that our function can't possibly capture everything. Maybe somebody's particularly in love with a house in a way which you can't model in any way, and so we add an error term to our unknown function. We represent each house by features, so we have a load of information about each house, which you would think the buyers and sellers also know about, otherwise they couldn't be using it to make their decision. These features feed our unknown function, plus some kind of error, to create the price. What then is the purpose of machine learning? Well, obviously, the purpose of machine learning is going to be to try to approximate this function. We will call the approximation of this function f hat of x. People say, therefore, that supervised learning is function approximation. The whole point of any supervised learning we do is that we assume there's an underlying real-life function, f of x, plus some noise, and we are trying to estimate that with f hat of x. Now, we have a data set which we will call D. The data we have isn't necessarily all of the data in the world. For example, the data we have on Amy's house prices is not the data necessarily of all of the houses in Amy's, or all of the houses in the world, or even all of the houses in a part of Amy's. In the polynomial regression that we looked at, we had 30 examples of training data, and how many? 3,000 examples of test data. In that situation, you can imagine that the whole world consisted of 3,030 pieces of information or examples, and we only have 30 of them. So our data set is D, and in fact, the model that we fit is f hat of x, but fitting only on our data set.